All right, good afternoon. Again, the third test will become available tomorrow at noon, and it will be available until the evening of Monday, April the 12th. And now, just looking again into the review items, and we have from the added test 3 review. Now, we looked at numbers 2 and 3 on Tuesday, and for what we have, just kind of looking at the rest of the items. And we have for number 1, again, just going back to quadratic functions. And we have a given function, f of x is equal to negative 3x squared minus 12x plus 17. And it's asking, does the function have minimum or maximum value? Okay, again, this is not a yes or no question. It is whether the value is going to be a minimum or a maximum. And we have for this given function. Okay, so again, we have the equation, or I should say the function, to be laid out in standard form. And what is going to be the minimum or the maximum is going to be referring to the vertex. Okay, so again, so we have f of x is equal to negative 3x squared minus 12x plus 17. And looking at translating this form over to the vertex form, and again, we can separate the variable terms apart from the constant 17. Okay, so we have negative 3x squared minus 12x. Again, we have followed by the addition of 17. And again, in terms of setting things up so as to be able to use the completion of the square, again, I'm going to rewrite what I have in parentheses such that the leading term inside is going to be x squared. So I had the leading coefficient right now at negative 3. And if I factor out negative 3 from negative 3x squared minus 12x, we have negative 3 times the quantity of x squared plus 4x. And you can double check. So again, we have negative 3 over x squared is negative 3x squared. Negative 3 over 4x is going to be negative 12x, and we have plus 17. Okay, now in crossing over to the completion of the square, okay, now we have the first term in the parentheses to be x squared. So with the completion of the square, okay, you look at the first order variable term, take the coefficient of that, divide by 2, and square out. So we have half of 4 is going to be 2. And that number is going to reappear in the vertex form. And the square of 2 is going to be at 4. And we have for f of x, we have negative 3 times the quantity. Okay, so we have x squared plus 4x. And we have plus 4 to follow. And we have plus 17. And again, I'm going to have to create a bit of a balance to get it back to the equal of negative 3x squared minus 12x plus 17. And by adding 4, I got negative 3x squared minus 12x, and I have minus 12 plus 17, which is going to be 5, but I want to get it back level with 17. So by adding 4 inside the parentheses, what I am doing in effect in the overall picture is going to amount to subtracting 12 at the front. So by having created this deficit at the front, I'm going to override this by adding 12. And so I'm going to have here in the rewrite, we will have f of x is equal to negative 3, again, times the quantity of x squared plus 4x plus 4. And 17 and 12 will make 29. Okay, You can see if it all balances. Okay, so you got negative 3x squared minus 12x. Again, negative 3 times 4 is negative 12. However, negative 12 plus 29 gets us back to 17. And now, for the vertex form, okay, so you have f of x is equal to, and we have negative 3, for x squared plus 4x plus 4. Again, we have a squared trinomial. Okay, and you can say that for x squared, again, we have the square of x, and how this whole trinomial came into formation. Again, we had completed the square upon adding 4, and this came into existence upon squaring out 2. Okay, so the vertex form, we're going to have f of x equal to negative 3. Okay, and we have times the quantity of x plus 2 squared. And we have followed by the addition of 29. Okay, so we have with this layout in the vertex form. Okay, so looking at the coefficients again, so we have with a, okay, we have that equal to negative 3. And since the a value is negative, you're going to have the graph to be opening downward. And it's going to open downward from the vertex. So the vertex is going to be the high point. So that is going to be the maximum of f of x. If the graph opened up, okay, the vertex would be a minimum location. Okay, and for what we have regarding the values, okay, so we have for x plus 2, if I set this equal to 0, okay, this is going to be the first coordinate of the vertex. So you have that h is equal to x is equal to negative 2. Again, we have the k value. Okay, the k value is going to be at 29. So you have the vertex hk. Okay, that's going to be at negative 2, 29. And just for what we have in terms of the items sought after. Okay, so we got, does the function have a minimum or maximum value? In this case, the vertex is going to be the peak point. So that's going to be the maximum. And it's asking, okay, where does the minimum or maximum value occur? And that's going to be your first coordinate. And this can be your x or h value, which is going to be negative 2. And for what we have in terms of the minimum or the maximum value, again, that is going to be the k value. Okay, and so again, we have the vertex at negative 2, 29. So the maximum value is going to be at 29. So in this case, we have y is equal to k is equal to 29. Okay. And just for what we have in the overall picture, again, So we got the graph of f of x equal to negative 3x squared minus 12x plus 17. And again, we have the location of the maximum, in this case the vertex. And again, it occurs at x equal to negative 2, and the maximum value is the corresponding y value, which is going to be at 29. Okay. Let's see. Okay. All right. Now we have, in the case, let's see, we already did 2 and 3. And now for what we have in the case of number 4, okay, it says to use synthetic division to find the quotient and remainder. Okay, here we have the divisor at 2x cubed plus 2x minus 9 all over x minus 5. And it says to write the answer in the form of the quotient plus the remainder over the divisor. So for what we have in the case of number 4, okay, so you have x minus 5, the divisor. And I can use synthetic division. Okay, since the leading term is x, there's no coefficient in front, and x is not to raise to any power other than 1. Okay, so you have like the double insurance coverage. Okay, coefficient is 1, and the degree of x is 1. And we have with the dividend. Okay, so we have 2x cubed. And I want all the degrees from the third order down to the constant to be represented. And if you notice, okay, we don't have an x squared term. So I'm going to use 0 for placeholder purposes. And then I have plus 2x followed by the subtraction of 9. Okay, now I could perform line division, but since it says to use synthetic division, okay, so I have x minus 5, and reformatting the line division setup along the lines of synthetic division, and we have taking the 0 of x minus 5, which is going to be 5. And again, with the coefficients. Okay, so I'm going to have, I'll just format this about like what Alex would have. I kind of like just that mini wall, but I'll just set it up like this, like in terms of how it would likely appear in Alex. So you still have 5 partitioned, and you have 2 for x cubed, 0 for x squared, you have 2 for 2x, and negative 9 for the constant. Okay, so we have with synthetic division, okay, we're looking at column by column addition. And so we have from the dividend, okay, we have leading coefficient is 2 from 2x cubed. I'm going to bring this down, 2 is brought down, and then I'm going to multiply. Okay, so don't multiply and then put in the column. Okay, I think I saw like a mistake where somebody multiplied the first coefficient from the dividend by the 0 and say like 5 times 2 is 10 to put 10 down. Now you don't multiply until the first number is brought down. So you have 2 is brought down. Then we have 5 times 2 is 10. Then we have 0 plus 10 is 10. Then you have 5 times 10 is 50. And we have 2 plus 50 is 52. Okay, and these numbers are getting larger here. Okay, and so we have 5 times 52 is going to be 260. And negative 9 plus 260, so that is going to be 251. And so for what these totals are going to represent, okay, so with the number 251, okay, that's going to be the remainder. And for what we have in terms of the quotient, okay, so I'm going from 2x cubed to 2x squared. You have plus 10x. We have followed by plus 52. And just for the display, for the quotient plus the remainder over the divisor. So you have 2x cubed plus 2x minus 9. over x minus 5. Okay, so this will come out to 2x squared plus 10x plus 52. Again, we have at the end. Okay, so you got the remainder at 251. And we have all over x minus 5. Okay, and so that will be the result in this format. All right, now for what we have in the case of number 5, okay, and we have for this item, okay, so we have going crossing over to the factor and remainder theorems, and this one it says to use the remainder theorem to find the quotient and remainder p of 2, given that p of x is equal to 5x cubed minus 4x plus 7. Okay, now just work over here. So we have yes, you have a polynomial. Okay, so you have p of x is equal to 5x cubed minus 4x plus 7, and okay, it says find the quotient and remainder, which you have represented by p of 2 I'm just mentioning, okay, so we have with p of 2, now 2 is a 0. And so the divisor here is going to be at x minus 2. And if you're looking for the remainder, say that if you're looking through the techniques of in the polynomial division, whether it's through line division or synthetic division. Okay, now the divisor we have x minus 2. Now the remainder would be p of 2. Now we have x minus 2 into the divisor, which we have at p of x. So you have 5x cubed. Notice we have a missing square term. Okay, so we'll have 5x cubed plus 0x. We have minus 4x. And you have plus 7. Now I could take the line division route, but I'm going to go with the synthetic again. So again, if x minus 2 is 0, again I have x is equal to 2. Okay, so again, going back to the 0. And we have in terms of synthetic division, okay, so you got 2. And with the coefficients, you got 5, 0, negative 4, and 7. Okay. And I'm getting the synthetic division display about like it would appear in Alex. Okay. But normally I like this kind of separating, but regardless, okay, it's still going to lead to the same result. Okay, so we have with the leading coefficient 5. Okay, I'm going to bring this down. Then we have 2 times 5 is 10. 0 plus 10 is 10. 2 times 10 is 20. Negative 4 plus 20, okay, is going to be 16. 2 times 16 is 32. And 7 plus 32 is going to be at 39. And we have, in the case of the totals, I'm just going to mention, now we have the remainder. That's going to be your p of 2 is equal to 39. And again, we have with the quotient. Again, we started out with a dividend at 5x cubed, and the quotient is going to be 1 degree less. So the quotient, okay, so this will be 5x squared plus 10x plus 16. And I'm just going to mention, okay, so you had this is the function, and again the remainder we have to be at p of 2. I'm just going to bring this up. Let's see if I can. Yeah, so just referencing what we have now for p of 2. Okay, so we have 5 times 2 to the third. We have minus 4 times 2 plus 7. And so we have 5 times 8. Negative 4 times 2 is minus 8. And we have plus 7. And we have 5 times 8 is 40. Negative 8 plus 7 is negative 1. And you come out to 39. Again, just restating the function value and the remainder, regardless of whether you're using log or synthetic division. Okay, those will end up as the same. It's got p of 2 in both capacities, but again, I use the polynomial division to get to the quotient as well, whereas the function value gets you only to the remainder. All right, now, and what we have with number 6, okay, and here we have going with the factor theorem, and you're looking at determining the remainder and then figuring out if x plus 2 in this case is going to be a factor of p of x. Okay, so again we have with p of x, then we have x cubed minus 2x squared minus 3x plus 10 Okay, so this is going to be the dividend. And we're looking at division by x plus 2. All right. So we have in terms of polynomial division. Okay, so the divisor we have at x plus 2. And again, I can use log or synthetic division directly. Okay, so again we have with the dividend, so we have x cubed minus 2x squared, we have minus 3x, and we have plus 10 at the end. And now for x plus 2, if I take the synthetic as well as the remainder and factor theorem representation of x plus 2 to the divisor, okay, we have x equal to negative 2, and setting up things along the lines of synthetic division. Okay, so we have negative 2, and we have with the numbers here, so I have 1 for x cubed, negative 2 for x squared, we've got minus 3 in x, we have plus 10, and we have with synthetic division, okay, so if I bring down the leading coefficient 1, so I have negative 2 times 1 is negative 2. And negative 2 plus negative 2 is negative 4. Negative 2 times negative 4 is a positive 8. Negative 3 plus 8 is 5. Negative 2 times 5 is negative 10. 10 plus negative 10 is 0. And guess what? For the remainder, now in functional terms, now you have your remainder. Again, so that would be p of the 0 in this case. You have p of negative 2. And that comes out to 0. And if the problem we're asking for the quotient, their quotient would end up as x squared minus 4x plus 5. Okay, so this is what we have in the collection. And again, so your remainder is p of negative 2, which is 0. And again, if I plugged in negative 2 for x here, you got would be negative 8. And then I have like minus 8, so minus 16. And we have minus 3 times minus 2 is a 6. So I have going from here, got minus 16 plus 6 is negative 10 plus 10 comes out to 0. Okay, so your remainder is going to be at 0. And again, for what we have in the case of 6, so we have with the factor theorem, and in the case of filling in the blanks, okay, so it's going to be that p of negative 2 is equal to 0. And because the remainder is negligible, because it is equal to 0, we would have that, yes, x plus 2 is a factor. If you had a non-zero value, then it would not be a factor. Okay. And once again, for what we have in the inequalities, okay, so we have with 7, okay, we got polynomial inequality, whereupon we have x squared minus 4x is less than or equal to 12. And just double checking, okay, so that was, yeah, less than or equal to 12. Okay, and again, if I rewrite this as a comparison to 0 inequality, so I can just move the 12 over by subtracting. So we have x squared minus 4x minus 12 is less than or equal to 0. And for that which is compared to 0, okay, we'll have that as our function to be used in the table as I apply each test value for the input. Okay, so you have f of x is less than or equal to 0. And we have, now we have with the setup, if I'm looking for the zeros, okay, so we have from the premise, say if I had x squared minus 4x equal to 12, and I rewrote this as a quadratic equation in standard form. Okay, so you have x squared minus 4x minus 12 is equal to 0. And we have with factoring, okay, so you have x minus 6 times the quantity of x plus 2 is equal to 0. And again, so if x minus 6 is equal to 0, okay, so you have that x is equal to 6. And if x plus 2 is equal to 0, so we have that x is equal to negative 2. Okay, so we have, again, just for the setup, we have f of x equal to x squared minus 4x minus 12. And now for the zeros. Now, the zeros are going to be in the domain for both 6 and negative 2. We'll set the function equal to 0. So you have with the zeros, we have at 6 and negative 2. And for what we have in terms of the interval setup, okay, so we have going from negative infinity, approaching but not including negative 2. Then we have those values past negative 2, approaching but not including 6. We have those values x greater than 6. Okay, so for what we have in the case of the possible input values, okay, so you have anything less than -2, okay, we might go with -3. And between -2 and 6, okay, we can go with 0. Anything greater than 6, okay, we might go with 7. Okay, we have with f of x. Okay, so again, this is going to be x squared minus 4x minus 12. Now for f of -3, so if I plug in -3 for x, so I have the square of -3 minus 4 times -3 minus 12. Now -3 squared is 9. And we have plus 12. We have minus 12. So the positive and -12 will go out. So we have positive 9 left over. And for f of 0, okay, well, for f of 0, variable terms become negligible. And so the output is going to be the constant at the end, which is going to be minus 12. And for what we have in the case of f of 7, okay, so you have, in this case, you have 7 squared minus 4 times 7 minus 12, so you have 49 minus 28 is going to be 21. Take away 12 from 21, and so that is going to be positive 9, just like the first case. And for what we have in the case of the sign of f of x, okay, so for any input less than -2, okay, we have a positive. So you have the f of x is greater than 0, and then we have in between -2 and 6, okay, so we have a negative output. So we have that f of x is less than 0, and then for any input greater than 6, the output is positive. So we have the f of x is greater than 0. So looking at what we have now, okay, so this is the inequality we started with, and translating in terms of a comparison to 0. Okay, so this amounts to where f of x is less than or equal to 0. So we have the activity to be in the same direction as f of x is less than 0, and in the case of the solution, okay, we have just referencing the middle column section here, so the limit values involved will be -2 and 6. And since both -2 and 6 will cause the function to be equal to 0, okay, -2 and 6 will be included, and so they will be placed inside of brackets. And so that'll be the interval solution for what we have in problem number 7. And for what we have regarding, okay, rational inequalities, now here we have one that is set up in terms of comparison to 0, whereupon we have x squared minus 4x over x plus 5 is greater than or equal to 0. Okay, so we have in this one, okay, so we got essentially r of x is greater than or equal to 0. And for x squared minus 4x over x plus 5. Okay, so if I'm looking for the zeros in the x expressions case, so we have with x squared minus 4x, if I set this equal to 0, okay, so I have greatest common factor, we have an x okay, so setting x to 0, have x equal to 0. And if x minus 4 is equal to 0, so we have that x is equal to 4. And from x plus 5, if x plus 5 is equal to 0, so we have that x is equal to negative 5. Okay, so just for what we have in the overall setting, so again we have r of x equal to x squared minus 4x all over x plus 5. Now for the zeros. Now from the numerator. Okay, so we have 0 and 4 to steal from the numerator factors, and you can have a 0 numerator as long as you do not have a 0 denominator. So 0 and 4 are going to be in the domain. And in the case of negative 5, okay, this will cause a 0 denominator where the function would end up being undefined. Okay, so negative 5 is not in the domain. And so in setting up a table of intervals, okay, so we have out of these, okay, negative 5 is the least of the zeros. Okay, so you have first interval, we have those values of x less than negative 5, and then you have those values between but not including negative 5 and 0. And we have bypassing 0, so you have those values between 0 and 4. Then finally we have those values of x which will be greater than 4. Okay. And the more zeros you have, the more intervals you have to work with. Okay, and just for the test value inputs, okay, so for anything less than negative 5, we can go with negative 6. Say between negative 5 and 0, then go with negative 4, negative 3, negative 2, even negative 1. And then between 0 and 4, we can go with 1. Anything greater than 4, we can go with the number 5. And again, the function we are working with, okay, again, so we have r of x is equal to x squared minus 4x all over x plus 5. And in the case of r of negative 6, okay, so you have what's going to be negative 6 squared, so that's going to be 36. Negative 4 times negative 6 is going to be a positive 24. We've got negative 6 plus 5. So we got 36 and 24 will be 60 over negative 1. And so we got negative 60. Now for r of negative 1, now the square of negative 1 is going to be positive 1. We've got minus 4 times negative 1, so that will translate to plus 4. Okay, so we have 1 plus 4. Negative 1 plus 5 is 4. And so we're going to have for the output, okay, so that is going to be a positive 5/4. Now for r of 1, okay, you got 1 squared is 1, minus 4 times 1 is negative 4, so you have 1 minus 4 over 1 plus 5, and so we have 1 minus 4 is negative 3, 1 plus 5 is 6, and negative 3/6 reduces to minus 1/2. Now for r of 5, okay, so you have 5 squared is 25, negative 4 times 5 is going to be negative 20, and 25 minus 20 is going to be 5. And we have 5 plus 5 is 10, and so we have 5/10 is reducible to positive 1/2. As for the sign of r of x, okay, so anything selected from the first, okay, we have a negative output. And the next categorical output, okay, we have to be positive. So we have r of x is greater than 60. Next we have to be a negative. Last we had to be positive. Okay, so just going back to our inequality and looking for the interval solution. Okay, so whereupon r of x is greater than or equal to 0. Okay, so we'll have in the case of the solution. Oops. Okay, so you have in the same directions where r of x is greater than 0. Stay still. Okay. Okay, so you have where r of x is greater than 0, so we're involving the limits negative 5 and 0. And also where r of x is greater than 0, so we are involving the limits 4 and infinity. With the equal sign, there is the possibility of there being brackets. Okay, now for the enclosure, now infinity is boundless, so that stays in the parentheses. And in terms of finalizing, okay, again, so 0 and 4, both of these are in the domain. So I can put these values each in the bracket. Whereas in the case of negative 5, that one is not in the domain because that will cause the rational function to be undefined as opposed to equal to 0. So this will be your interval display for x squared minus 4x over x plus 5 is greater than or equal to 0. So you have parentheses around -5 and infinity, and 0 and 4 in the bracket. All right, now for what we have in the case of number 9, okay, so you have x plus 2 over x minus 6 is greater than or equal to 0. Okay, and this rational function, okay, we already had this in simplified form. So we had the r of x is greater than or equal to 0. And again, for x plus 2 over x minus 6. If x plus 2 is equal to 0, so we have that x is equal to -2. And for x minus 6 equal to 0, so we have that x is equal to 6. All right, so we have with our function r of x, okay, so you have equal to x plus 2 over x minus 6. And for the zeros, okay, so we have -2, and since this stems from the numerator factor, okay, I can have a 0 top part of the fraction, but not a 0 bottom part. So -2, okay, so that one is in the domain. And on the other hand, we have with 6, because this comes from the factor in the denominator. Okay, that one is not in the domain. And in the case of the intervals, okay, so we have starting from -infinity, approaching -2. You have between -2 and 6. And finally, we have that set of values x greater than 6. Okay, now for the test values, again, we have in the first of the groups, okay, so you have for any input less than -2, we can go with -3 as a possible choice. And between -2 and 6, okay, 0 is a possible choice, and anything greater than 6, we'll just go with the number 7. And here we have r of x is equal to x plus 2 over x minus 6. Now for r of -3, okay, -3 plus 2 is -1. -3 minus 6 is -9. And the negatives are going to cancel out. So this will come out to a positive 1/9. And for r of 0, okay, so we have 2 over negative 6, and that is reducible to minus 1/3. Okay, and for what we have in the case of RF7, okay, so we have in this one, I don't want my computer to die on me. Okay, so I have in the case of RF7, okay, so you have 7 plus 2 is 9, 7 minus 6 is 1, and so we have for this output, okay, so that's going to be a positive 9. And for what we have in the case of the sign of R of x, okay, so you have a positive, so you have R of x is greater than 0, then next we have a negative, so we have R of x is less than 0, and then we have last, we have a positive, okay, so we're going to have the R of x is greater than 0, okay, and so we're going to have here okay, so you have x plus 2 over x minus 6 is greater than or equal to 0. And so referencing the limits from R of x is greater than 0. Okay, so you have between negative infinity and negative 2, as well as those values greater than 6. And again, infinities are boundless, so we use parentheses. And now for the zeros, okay, you have negative 2 is in the domain, 6 is not in the domain. So negative 2 is going to be in the bracket, for that will set the function equal to 0, whereas 6 will set it undefined. And so the 6 is going to be in the parentheses. Okay, so there's only one bracket, and that is going to be around negative 2. And for what we have in the case of number 10, okay, and we have in this comparison inequality, okay, so now we got x over x plus 6 is greater than or equal to 1 over x. Okay, so you have a comparison between ratios, and if I write in terms of comparing to 0, so you have x over x plus 6, you have minus 1 over x is greater than or equal to 0, and if I consolidate these terms into one rational expression, okay, so just putting these in terms of the least common denominator. So least common denominator, okay, so we have x times, okay, we have the quantity of x plus 6 so for x over x plus 6, okay, so I have the x plus 6 factor, but I'm missing the x. So I multiply by 1 in the form of x over itself. Now I've got subtraction. Now for 1 over x, I have the x factor, but This one is missing the x plus 6, so I'll multiply this ratio by 1 in the form of x plus 6 over itself. Okay, so we have in the adjustment, okay, so for the first ratio I have what's going to be x squared all over x times, okay, the quantity of x plus 6, and we have minus, okay, now we got x plus 6, and we have all over the quantity of x, or should I say all over x times the quantity of x plus 6. Now, so look at gathering the fractions. Okay, so we have x squared. Now, if you notice, both x and 6 will be affected by the subtraction in front of it. So altogether, we're going to have x squared minus x minus 6 all over x times, okay, the quantity of x plus 6. And this numerator can be factored, so I'll just go ahead and express this in factored form. So I'm going to have x plus 2 times x minus 3 and we have all over x times the quantity of x plus 6. Okay, so we have with our inequality, and making the adjustment. Okay, so combining these ratios. Okay, so we have all together. Okay, so we have x plus 2 times x minus 3. And again, this is going to be all over x times the quantity of x plus 6 is greater than or equal to 0. Okay. So I have this is our r of x, whereupon we have r of x is greater than or equal to 0. Okay, so we have in the formation, okay, so you have r of x, okay, so you have x plus 2 times x minus 3. We have all over x times, okay, the quantity of x plus 6. And I'll go ahead and identify the zeros. Okay, for x plus 2, the 0 of this is going to be negative 2. And since that factor is in the numerator, okay, that one is in the domain. For x minus 3, if that is equal to 0, we have x equal to 3. Again, because x minus 3 is only in the numerator, okay, that is in the domain. And as for x and x plus 6, the corresponding zeros will not be in the domain. Okay, so from x I have 0, and from x plus 6 I have negative 6. So I have not in the domain. All right, so we got 4 distinct zeros. And just setting up our table of intervals. Okay, so out of these, negative 6 is the smallest. Okay, so between those values less than -6. Then we have those values between -6 and -2. And then we have between -2 and 0. And then we have between 0 and 3. Then we have those values x greater than 3. And for what we'll have in the case of the test value inputs, okay, so anything less than -6, we can go with -7. Between -6 and -2, -3 is a possible choice. And if I stick to integers, okay, we have only -1 exists between -2 and 0, and between 0 and 3, I can select 1. Anything greater than 3, I can go with the number 4. Okay, and just taking what we have for the rational function. Okay, so we have with the inputs. Okay, so for x at -7, so we have for r of -7. Okay, so we have -7 plus 2 is -5. -7 minus 3 is -10. We got -7 times -1. Okay, so that'll come out to positive 50 over 7. Now for the next input, for r of -3, okay, so you have -3 plus 2 is -1, -3 minus 3 is -6, we have -3, and we have -3 plus 6 is 3. So this will go to 6 over -9, and this ratio is reducible to -2/3. Now in the case of what we have for r of -1, okay, so you have -1 plus 2 is 1, -1 minus 3 is -4, we got -1, -1 plus 6, okay, that's going to be 5, so I have -4 over -5, so that ratio reduces to positive 4/5. Now for r of 1, okay, so you have 1 plus 2 is 3, 1 minus 3 is -2. You got 1, and 1 plus 6 is 7. So for this output, okay, this will be a -6/7. And for what we have in the case of R of 4, okay, so you have 4 plus 2 is 6, 4 minus 3 is 1. You got x at 4, 4 plus 6 is 10. Okay, and so you have 6 over 40, and that is reducible to 3/20. Now for the sign of R of x, okay, so we have for the first group, okay, we have positive, and it looks like we'll have alternating throughout between positives and negatives. Okay, and in terms of what we have for the original inequality, okay, so just for the progression, okay, so this conversion is going to be in terms of a comparison to 0 inequality. Okay, this will be in the same direction as where R of x is greater than 0. And in the case of the interval solution, okay, so greater than 0, so you have between negative infinity and negative 6. You also have between negative 2 and 0. And finally, we have between 3 and infinity. Okay, and with the inclusion of the equal sign, there could be at least a bracket. Okay, now again, just grouping. Once again, infinities are boundless. So you have parentheses. Now, looking at negative 6 is not in the domain, so that stays in the parentheses. Negative 2 is in the domain, so we can bracket that value. 0, okay, that one is not in the domain. And as for 3 is in the domain. And so that will be in the bracket. So for x over x plus 6 is greater than or equal to 1 over x, and after having converted as a comparison to 0 inequality, and looking at what we have formulated and to result in the table, and separating what is in the domain from those zeros not. Okay, this is mere interval solutions. So we have those values x less than negative 6, along with those values of x such that negative 2 is less than or equal, to x, which in turn is going to be less than 0, and you have those values of x such that x is greater than or equal to 3.